This video is going to talk about compound interest. In the last video, we talked about simple interest, in which that interest payment was only applied to the principal. Compound interest is more realistic. We're going to see this one more often throughout investments and loans. And this is the type of interest in which basically your interest earns interest. So the interest is applied to not only that principal, but also the previously earned interest. It is a relative constant growth situation, which means we are looking at an exponential function. And so you could just think of it as an exponential function. It does get its own sort of unique formula we're going to talk about. And you'll notice I've changed up the variables slightly here. They're similar to the ones in the previous problem. They might not be the variables you traditionally see. And part of the reason for that's going to become clear in our next video, in which we talk about a special calculator that will help us deal with these types of problems. So we still have our principal right here. So we start with sort of the amount we want to invest in our account. And we end up, sort of our FV, that's the same thing as our A value. It's sort of the amount that you're going to pull out of the account at the end. But right here, this should look familiar to you, this 1 plus something, 1 plus the rate. That's exactly what we had in an exponential function. The only difference here is that you should notice that the rate setup's a little different. And that is sort of because the compound interest. It's not just 1 plus R this time. We have R divided by this thing called N. And N talks about this notion of compounding periods. So what is a compounding period? Well, basically, a compounding period is how frequently the interest is going to be applied throughout the year. So often with loans and credit cards, interest is often compounded daily, though in some of our problems we'll simplify that a little and we'll talk about it being compounded monthly. But basically, how often is that interest sort of factored into your account? Now, why we take the rate and divide it by N is because when we are given that rate, we're often given it in its annual form. So that's like a percent over a course of a year, and we want to split that percentage up to reflect the number of compounding periods we have, which is why you'll notice sort of the N here as well as the N up top, because depending on how many times you're applying that sort of interest throughout the year, we're going to actually then need to multiply by that percent that many extra times, which is why we sort of have it up in the exponent. That's a little bit of the math behind the formula. We're going to practice using it, and hopefully it will sort of make sense. The other thing you'll notice up top here on this note sheet is I've given you this is just sort of a helpful resource. These are common compounding lengths of time and sort of what number goes with it. You'll notice down at the bottom there is a compounding continuously. It is possible to always be compounding. We are not going to look at problems like that this semester, but it's there. It's possible. All right, so we're going to go back to Trevor and his $6,000 he deposited in that really low interest paying CD. And so part of the goal here is to look at what is the difference between him depositing in a account that used compounding interest versus one that didn't. So we're going to start with a pretty simple one. It compounds annually, so that's just one time a year. But what makes it different than simple interest is that our interest gets applied to the interest. All right, so how much is in the account after 1 year? And then how much interest is earned? So if I'm going through and figuring this out, I would have my principal still. So this is my principal. Remember, this is my sort of rate. And then my N value this time is going to be 1 because I'm compounding once in every year. So if I sort of plug into my formula, I have 6,000 times 1 plus, and then that rate as a decimal still, and then divided by 1, and then my exponent is just going to be to the first power because we're only looking at 1 year later. And what you'll find is, if I multiply this out in my calculator, and I did this in advance in my calculator, I get $6,051. So how much extra do I have for my principal? So to figure out my interest, so interest in this case, and I'll actually make a note of that up here just so we can sort of remember that. So if we want to find interest, we're going to take our future value and we're going to minus our principal. Okay, and so going back, 6,051 minus 6,000, we made $51 in interest. And you might be going, well, that's no different than our simple interest account. I might as well left it over there. Yes, year one's not going to make any difference. It's what happens in year two where we're going to start to see the change, because this time, instead of continually applying that interest to the $6,000, this time the interest is going to be applied to the $6,051 that are already in the account. So if we were like just sort of going by hand and doing it year by year, it would actually be that you would take that $6,051 and then multiply it by that sort of percentage growth, and you would wind up with a slightly extra amount. Now, because we're dealing with compound interest, what it would look like if I wanted to do 2 years at a time in the formula, I would still have that 6,000, 1 plus 0.0085, and this time I'm going 2 years, so I raise it to the power of 2, and I end up with $6,102.43. You might be going, well, that's not that much more. It's a little more. You earned 43 cents extra. So, that compounding earned you 43 extra cents. I'll take it. It's not that bad. It's not a ton, but it's a little bit extra. It's a teeny percent growth. So it's not like you're going to be, making millions in a year. So a little bit extra. But here's the thing. The longer the money sits in the account, the more that little bit extra is going to be. So what would have happened if we go back to that sort of 10 years? So remember, in 10 years, we want to know how much extra this compounded interest is going to make. So let's say, okay, so we take 6,000. And then we have 1 plus the 0.0085. And this time we're going to raise it to the 10th power because we're 10 years later. And it was times 1, applied interest annually. And if I put all of that in the calculator, I would end up with $6,529.96. So the question is how much more did we make than our simple interest problem? Well, if the compound, we have that amount. And with our simple interest, we only made $6,510. And so over 10 years, we made $19.96 additional. So that's sort of the extra money due to compounding. And you might be going, it's not that much, but I'll take it. It's sort of like, who doesn't want some extra money? It's $20 extra. And so that's a very basic compounding situation. So we're going to just take it, obviously, a little bit further. So let's say Trevor found a different account, because typically if accounts are going to compound, they're going to compound more frequently than annually. So in this case, it's the same interest rate, but we're going to actually compound it monthly. And so in this case, that end value is going to be 12, because the interest is going to be applied 12 times throughout the year. And we still want to look at that 10 years later, and then we want to figure out the interest earned. So we have a few different things we want to do here. So let's start with our compound interest formula. So we have our $6,000 in principal, and then 1 plus the point, now here's where it changes. So instead of just plus that 0.0085, we're going to actually take that sort of percentage and we're going to split it up to sort of 12 instances throughout the year. And then we're going to take our 10 years And for each of those 10 years, we need to apply the interest 12 times. So we sort of a higher power going on up there. And if I put all of this in my calculator, I would end up with $6,532.11. So notice a little bit more than our plain old annual compound interest. Not a ton more, but just a little more. And so if we want to figure out the interest earned, we would take that $6,532.11 and we'd minus our $6,000, our initial investment, and we would have an interest earned of $532.11. So it earned about $2 of extra interest in compounding that monthly. So sort of the more often it compounds, the more money you would earn in your account. So that's a pretty basic compound interest formula problem in which we are asked to figure out sort of our final amount given number of compounding periods and interest rates. We'll look at some more complex compound interest formulas in a future video.